Hello, everybody. So we are going to compare expressions using algebra tiles and algebra mats. This is from course 2 from CPM, and just wanted to give you an example of how this might look. And this was just kind of classwork problems that we were doing. So this particular problem said to build the two expressions on your mats using the algebra tiles. So they're going to want us to build this using algebra tiles, and then write the expression for each side. For mat A, what expression is this? For mat B, what expression is this? And then to use legal moves to determine which mat is greater if possible. So if I just wanted to write an expression just right here for this, I could write it, right? I could say, well, there's 1, 2, 3, 4, 5, 6, 7 positives, right? 7 positive 1 tiles. And I see 1, 2, 3 negative x's, 3 negative x's, plus I see a positive x, plus I see a negative 1. Right, that's kind of sloppy. So one thing I do is I like to just simplify it. I like to simplify it first. So instead of doing that, what I could do, and I'll take my algebra tiles that I have here, right here. Here are my algebra tiles. So take, here's mat A right here, already built for me. And what I can do is I can take my 0 pairs. So I can say this negative x I can get rid of it if I have the positive x join it. So that's a 0 pair. Negative x and positive x make 0. And I could take this positive 1 and the negative 1, and I could bring those guys and make that a 0 pair and bring those away. I can't, these aren't equal. They're not, positive 1 is not the same as a negative x. So that has to stay. Let's bring myself down here now. What I do have is I have a bunch of 0 pairs here. Here's a 0 pair, here's a 0 pair, here is a 0 pair, and here's a 0 pair. So I can take all those guys. Let's see if I can get them all. I can take all those 0 pairs and remove them. Oh man, this makes it so much nicer. So when I go to do that on my paper, I like to do this. Let's get a red pen. And I can take a negative x with a positive x and get rid of that. I can take one of these and one of these and get rid of those. And over here, I could get rid of these 4 negatives with the 4 positives with the 4 negatives. And now what am I left with? My expressions are so much cleaner now. I've got negative 2 x's, I've got 2 negative x's, and 1, 2, 3, 4, 5, 6, plus 6 positives. And on mat B, I have negative 2x plus 1. And I'm asking to compare. So I'm going to say, which one is greater? Now, I can see that the 2 negative x's are the same on both sides. And so the really only difference is that mat A has more positives than mat B. But what else it's asking you to do is, can you remove any balanced sets? I forgot what it was called. Move any balanced sets, things that are the same on both sides. So if I go back to if I go back here, I'm looking at, is there something that's the same here that's the same over here? Well, yeah. I can take these 2 negative x's and remove them, and take these 2 negative x's and remove them. And I see that, well, there is a positive 1 and a positive 1. So I can take both of these and remove those. It's fair. I've done the same thing to both sides. So now what I'm left with is really just a comparison of mat A and mat B. And I can really see that what was different about the two is that mat A has 5 more than mat B. So I know that this side is greater. That's all this is saying, is that after this is all said and done, after I get rid of, I'm going to do these in blue. So these 2 match with these 2. So I can remove those guys. And this 1 positive matches with that 1 positive. So what I know now is that this is greater. I know this is greater because of these 5, because of those 5 positive tiles. Oh, let's see. Uh-oh. All right, so let me pause this for a minute.